Cool. Thank you, Jason. Thanks, everybody, for sharing your evening with us. So my name's Aaron Gardner, Senior Scientific Consultant with BioTeam, also direct our product development strategy within the company. John Jacquay is with me, and we actually go back before BioTeam. But, you know, John's really just become, I guess I can best say, an invaluable collaborator and teammate for a lot of the cool development stuff that's been blossoming in BioTeam recently. So he's going to tell you about his recent work in a second, but I guess I'd be remiss if I just didn't quickly, for everyone, say who is BioTeam and why does BioTeam care about iRODS. So BioTeam's a consultancy, I guess I'd best put as a bunch of fallen scientists and research support types that had to understand computing, you know, truly and deeply to move the research forward. In the process, we kind of all found each other, started, you know, kind of offering these services to other organizations, and now 14 years later, we've been in and out of over 400 organizations spanning every vertical in the life sciences you can think of. We're really blessed to be considered kind of industry experts and best practice type folks that really do all kinds of things, from scientific computing assessments at the organization level to getting into nuts and bolts and doing custom development, HPC, cloud, et cetera, et cetera. So data management has really, you know, continued to chase up there to become maybe, you know, one of the top, if not the top issues, you know, screaming at us right now. And you know, we've seen for a long time iRODS as one of the best ways to address this. For John and I, iRODS goes back, you know, again, even before BioTeam, to University of Florida. I remember 6 or 7 years ago meeting a gentleman with a twinkle in his eye, Regan Moore, at supercomputing, telling me about iRODS, and we started working with it at UF. John joined our team actually along the way there, and then after moving to BioTeam, him and I stayed in touch. We kind of really just talked a lot about, you know, design and, you know, development principles, and we're looking in the Go and Golang, you know, so Golang and CGO and things like this. And then John really took it upon himself to kind of prove out a test case at UF with could he kind of apply the methodologies we were talking about to iRODS. And so since then, he's joined BioTeam, and we've kind of, you know, not only adopted him, but this work he's been doing, because we see it as a really great way to add value on top of iRODS and kind of build that last mile that will help us make iRODS actionable and production ready in our customers' hands more easily. So, you know, I guess without further ado, John, show him the cool stuff.
All right. Hi, everyone, and thank you, Aaron, for the introduction. So my name is John Jacquay. I'm a scientific systems engineer at BioTeam. And today I'm going to talk to you about one of the more recent projects I've been working on relating to iRODS, and obviously this project is called GoRODS. So the idea of GoRODS was originally conceived while I was working at the University of Florida's Interdisciplinary Center for Biotechnology Research. That's a mouthful. And GoRODS was a component of a larger data management and delivery system for U.S. core facilities. BioTeam has been very gracious, like Aaron said, by allowing me to continue development after I was hired on in August. And we really just love iRODS at BioTeam. It's really becoming a key piece of middleware in a large number of projects we're working on. And I'd like to think that this is because iRODS is just plain awesome. It's really powerful because it's you know, got a distributed storage architecture. It's got great metadata management and a good rule engine. So essentially, GoRODS enables the fast and easy iRODS client development in the Go programming language. So let's jump into the technical details. All right. So what exactly is GoRODS? So GoRODS is an iRODS client library, otherwise known as a package in Go terminology that's written in the Go programming language. More specifically, it's a Golang binding to the iRODS key API, and it implements the built-in pseudo package called CGO to invoke iRODS client functions that are written in C. The benefit to this is there's no shelling out to you know, your iCommands. It's a single call stack inside of your client, and it can be compiled into a single binary or shared object. So those are kind of some of the benefits of using CGO. And just to give you a little more background on myself as a developer, I typically write code in Ruby or JavaScript, but I've recently fallen in love with Golang. I found that you can write really fast and efficient web applications in Golang, and I wanted to have the ability to integrate my web applications with iRODS, and that's sort of how iRODS or GoRODS was born. All right, so you might be thinking, why Golang? What's the point of another language binding? And that's a good question. And to answer this question, I think we need to look towards the benefits of using the Go programming language itself. So it's got a really simple stack. The syntax is easy to write, it's easy to read. The performance is awesome, it's super fast, and besides the code that you write, there's only a small Golang runtime that has to be executed. It's got a dead simple concurrency model, so it's really easy to write concurrent code. It just consists of prepending Go before a function call, and that function is essentially executed in the background as a separate Go routine or thread. It's super easy to deploy applications that are written in Go. As I said, you can compile everything into a single static binary, and it's just a matter of copying that binary to whatever target system. Golang has a really great community. Pretty much anything you'd want to do, with a programming language, you can find the package either written by the Go core team or published by the community. And in my opinion, Ruby, Python, and Node.js are just plain over. They're too old to be considered hip programming languages, so as far as I'm concerned, they don't exist. And most importantly, it's not written in C++. But if you ignore my jabs at these other programming languages, I think it just boils down to personal preference. I enjoy writing code in Go and can be productive, and I think Go really balances the ease of use and execution efficiency very well. All right, so what can you use GoRODS for? Here are just a few implementation ideas. You can write web applications. Go has a really easy to use standard library for writing HTTP servers. And obviously with that, you can write RESTful APIs. And I also think GoRODS would be a good candidate to act as a bridge to and from powerful compute hardware for metadata extraction. So what I mean by this is if you've got, an iRODS storage system that you're wanting to offload some of the, the computing onto a separate server, you can use GoRODS to read data objects and extract metadata and then re-ingest the metadata back into iRODS. So this can be used for computationally intensive data analysis. You can run it on specialized hardware that has GPUs or FPGAs, and that hardware can run specialized algorithms such as neural networks or machine learning. And obviously, there are a number of different ways you can achieve this using TEPs and rule engines. So GoRODS is just one way that I was thinking of. All right, so I keep saying that Golang is simple and easy, so let's put some code where my mouth is. In this example on the right, you'll see that we declare our main package. We also import a few standard libraries for formatting and logging. And then we import our GoRODS package. And this is actually a GitHub path or a GitHub URL that Go will automatically download and compile for you when it finds it in the source code. So I really like that feature about Golang. In the first code block, you'll see we instantiate a client, and we pass in a few connection options such as host, port, zone, and your iRODS credentials. And after that, we just ensure that the client initializes successfully and that no errors occur. If an error is occurring, it'll log that and terminate execution of your program. In this next code block, we're simply opening a collection and we're passing in a path. And then in this callback function, once the collection is open, we're outputting the collection string representation. And this would be similar to the text output you would see from ILS. We're also looping over these data objects and collections using a GoRODS iterator and outputting the name to the console. So as I said earlier, I'm mainly a Ruby developer, so the Ruby developer can write code in Go. Just think of the possibilities. All right, so what about writing something useful like the web UI? Well, GoRODS has you covered straight out of the box. There's a file server struct you can instantiate, and this code is very similar to the previous example, but instead we pass a few options to this file server struct. We declare a mount path, and this is helpful if you're running proxies in front of your web server. Then we create a new serve multiplexer. We pass in our mount path and our file server, and then we listen and serve on port 6060. So this provides a simplistic REST-ish API to data objects, metadata, ACLs, and other things. The file server struct supports pluggable views written in Go's context-aware templating DSL. And using these pluggable views, you can customize the HTML and CSS to fit your needs and your organization's style. And one of the things I really love about Go's templating system is it's context-aware, which basically means it will automatically serialize or state variables based on their location in the HTML document. So variables output inside of a script tag will be JSON encoded, and variables inside of an HTML body tag or an HTML attribute will also be escaped based on the context within that document. So I think that's really cool and powerful. All right, and here's a screenshot of what you get out of the box with GoRODS if you instantiate that file server struct. And later on in this presentation, I'll give you a live demonstration of this. All right, so now on to performance. I think the main way we got good performance out of GoRODS is just shortening the execution stack. So you'll see these two diagrams on the left, and that just kind of shows you that using Go, we were able to kind of compress that execution stack. So we've been testing and optimizing performance in GoRODS, and so far, the numbers are looking great. We're getting practically native speeds for iPut and iGet operations versus iCommands. And for ILS operations on very large collections, GoRODS has actually outperformed iRODS REST, which that's the Java implementation. So GoRODS isn't perfect. There are a few functions that don't perform as well as the iCommands. So we're actually looking for community assistance for optimizing those cases. And also just to note, binding to the C API rather than writing the netcode in Golang ensures easier upgrades when new versions of iRODS is released. And I think this because you know, typically the C API will be less susceptible to change than the underlying transport protocols that are used by iRODS. All right, so I also want to give a demonstration of Golang and GoRODS' flexible memory management. So in this first example, this is an example of some suboptimal memory copies, and the source is from an older version of the HTTP handler.go file that's found in the GoRODS repository. So first, you can see that we're reading a data object in about 10 megabyte chunks, and this is just to keep memory usage low. So for each chunk, it's passing the data into a output buffer, and all of this is executed in a separate Go routine. So as soon as the buffer has content, this for loop will run and actually write the response to the HTTP stream. So this coding style is very helpful to the coder. There's really no chance of memory leaks, but it's not super optimal, which I'll explain in the next slide. And I'm not really an expert on other language bindings, but I assume that you know, other bindings to Python or other scripting languages would probably have the same the same data copy inefficiencies unless they write their own netcode. All right, so here's the CPU profile graph of the previous code example I showed you. And there's a lot of information to dissect, but essentially it's showing that the total CPU time of my test application is coming in at 970 milliseconds. So then this profiler times each function call on the stack and gives you a breakout of the time the function took to execute and its percentage relative to the total execution time. So you'll notice that the memory copy to a garbage collected Go slice takes almost as long as the API call that transfers the data over the network. So you'll see here that here is the read data object API call. This actually transfers the data, and then here is the here's where the data is converted into a garbage collected Go slice. So the data transfer takes about 350 milliseconds. The data copy takes about 300 milliseconds. So this isn't super optimal, as you can see. So as a better solution, I've actually been able to uplift the C memory management into GoRODS and into the API for better performance. So notice in this code example that there are a few differences. Instead of calling data object.readChunk, we're calling object.readChunk3. And all that's signifying is that, hey, once you get your data, you need to make sure you free it after using it. So here you can see as we're writing to the HTTP stream, after we're done writing the byte contents, we're actually freeing that memory node. So here's the CPU profile of that second example, and you can see that the overhead of the data copy is totally eliminated. The total time is 430 milliseconds as opposed to 970, so that's a reduction of 44%. So I was pretty excited to see those numbers. All right, and there's a lot of other features of GoRODS. It's got a complete API documentation on godoc.org. There's lots of code examples for common usage provided in the repository. GoRODS supports PAM authentication, supports ticket-based authentication. In this case, you can actually set tickets, but we haven't yet implemented the ability to create tickets, but that's definitely a feature in our pipeline. And GoRODS also supports user and group creation and management. And we almost have a full implementation of the iRODS client API. We're still working on a few iAdmin features for zone and resource management, and those will come later on as a point release, hopefully pretty soon. And there's lots more. All right, so now I'll give you a demo of the HTTP interface. All right, so here we have the HTTP interface running on port 6060. As you can see, you can browse through the collections, and this is just the GoRODS Git repository I've uploaded to iRODS. So you can browse, you can view stat information, you can view metadata, you can add metadata. You can adjust the permissions using the ACL tab. So we'll go ahead and give the group public write access. So all of this is taking place in the background using the REST-ish API. You can also create collections, and you can also upload data objects. So just in those few lines of code you saw, there's a lot of functionality packed in there, and you can really use, you can write your own code to extend this and you know, add more functionality. All right, so the roadmap for the next releases of GoRODS, I don't know if we have enough time to actually push the tag today, but or during the presentation, but we're gonna push the 1.0 tag today, and it's being released under the ESP 3-clause license, which is the same as iRODS. Version 1.1 is beginning development, and in 1.1 we'll add the remaining iAdmin functionality, performance optimizations, and a complete test suite. 1.2 will incorporate performance and feature improvements based on community feedback and early BioTeam production use cases. And as a community, we'd love to see pull requests. Any help we can get is definitely appreciated. All right. So the resources, you can find the GoRODS repository at github.com/my last name, which is long and hard to spell, /GoRODS. You probably want to Google search this, but in the results page, don't confuse it with GoRODS or GoROD, which is the death metal progressive jazz band, although I'd like to think GoRODS is just as cool. And this repository location could change as BioTeam fully adopts the project into its open source strategy, but that shouldn't really affect your code. GitHub should gracefully handle the redirects. My email is john@bioteam.net, so if you have any questions or comments, feel free to shoot me an email. And yeah, so now we can answer any questions you might have. All right, so thanks for listening.
That's outstanding. Thank you. Could you show us some of the science behind that file server? It seems to me that is following some standards, I would imagine, either via Go itself or the GoRODS interface. Is that something we could take a quick walk through?
Sure. You're wanting to see the code that kind of backs the web UI I showed?
Yes.
Okay, yeah. All right. Can you guys see my code?
Yes.
All right. So this is the HTTP handler. So this is the code, obviously, that backs the web UI I showed you. It implements the serve HTTP Go interface. So if you have an application that you want to serve out over HTTP, all you have to do is implement this interface, and from there, that's actually plugged into the Go multiplexer right here, and then that is passed into listen and serve. So in this file, you'll find the actual HTML template. This should be external, really, but I kind of combined everything into a single file for ease of deployment. And this is where you can actually use Go's templating language and the automatic encoding of variables based on the context happens here. So up here, I actually...
So this template describes basically all of the JavaScript, HTML, what have you, that is driving the web page on the client side?
Yes, that's correct. And it also implements the REST API. And that code can be found down in this section. So here are all the functions that are called from the REST API. So you have your add meta AVU, delete data objects, delete meta AVU, create collection, etc. So these are all the handlers.
I was just going to say, Jason, that's what's mind-boggling about this design pattern. And John and I, kind of talked about, what should be part of GoRODS, and, you can imagine BioTeam likes the idea of creating, being able to offer as a service, creating rich web applications on top of iRODS, but we felt it would be useful to the community to kind of have this single file design pattern to, kind of give the community a kickstart. But yeah, it's a single stateless binary. You can shard as a microservice as wide as you want, and that's all there is to it. It doesn't even need a web proxy in front of it. So that's the John magic, TM.
Thank you.
How is authentication handled and that sort of thing?
In this case, in the demo I showed you, all the authentication and the credentials are actually hard-coded. So here you can see that we're passing in our username and password. You can also pass in a ticket if you'd like, and the client will authenticate with that. In some other applications I've implemented, what it does is we use PAM authentication, and we connect initially and authenticate against PAM. And then we grab the PAM token we keep that in memory, and we actually encrypt that and send that as a cookie to the client. So the client, every time that makes an HTTP connection, it'll provide that encrypted PAM token, which the web application will decrypt. You can actually pass in the token. Instead of saying password, you would just say like PAM token. So that way, it's kind of a secure way to authenticate your users against iRODS without having to have like an intermediate user database table.
Nice.
You said you were going to release live on the presentation here?
Yeah, if we have time.
I think you've got time for that, certainly.
All right, let's do it.
Don't push it.
You're
Don't
starting
push
to
it.
sing, Terrell.
I know.
Another question is, do you have plans to implement the iRule command?
RS exec my rules.
I think eventually we'll probably implement that. It wasn't really a requirement for any of the applications we were building. And we're also really looking into the new pluggable rule engines, which can use the static compiled code, in which case the iRule command isn't really usable, I think, since there's no like DSL or scripting language backing it. So I think eventually we'll add it, but right now, it wasn't really our top priority.
Some community effort, perhaps.
How did you get the profiling information?
The profiling is actually part of Golang standard toolkit. So it's really simple. You include the runtime pprof package right here. And I'm not sure if I have an example, but essentially in a separate Go routine, you can actually write the profiling information to a file, and later on, there's a command that you can use called Go Profile, which you pass in that binary file, and from there you can generate SVG, HTML, PNG graphs of your code's execution. So we find that a really cool feature of Golang.
And this is really how we want to be engaging with the community in terms of driving iRODS production performance. If you scour things carefully, you can see like new RFCs coming out for NFS to combine RPC operations and do single round trip type stuff, right? So we would like to see these kinds of things happen in iRODS, and we saw this Golang and Seago pattern as a way to be able to be in lockstep with iRODS and really get in deep in minimizing request latencies and improving parallelism and things like that, and reducing memory copies, so that we can really, in some ways, supercharge iRODS performance and help provide good data for that with our last mile efforts.
Well, that's outstanding work. Thank you all.
All right. Well, thank you for listening. I really appreciate it.
So that tag got pushed we saw? There wasn't even time for applause.
We didn't even clap or anything.
No.
Yep, I believe so. So the tag is live. We should be able to navigate to our GitHub account and see that release, which I'll probably need to add some a description to that.
Outstanding.
Awesome.
I will have to go pull.
All right, thank you.
Look at that. Right.
Nice. Are there any other questions about this or anything else related to BioTeam before we move on? Going once, going twice.
I'll hang around after Jason if needed. So
Awesome. Thank you,
I'm interested in what's next.
Question.
What is
How,
How?
no, how's not here. How you doing? This is Cesar from iRODS. How are you parsing and deciding where to actually pick the pieces of HTML? Everything seems to be on just like one string of data inside that file. How do you parse that out? and decide what piece to actually start displaying. And was that based on any standards for your your graphic user interface, or like? I mean, it's very the example that you showed is very simple, but it's very clean. Is this following any like other libraries, like Bootstrap or?
Yes. So I'm actually in the example using Bootstrap, and the way basically beyond Bootstrap, the only library I'm using is GoRODS net HTTP, which is a pretty low-level interface for creating HTTP servers. So depending on the request type, so if it's like a GET, first the code will actually check to see if that's a data object or a collection. If it's a collection, it will render out the view, which is that whole template string. And if it's a data object, it will actually read the data and actually serve that out over HTTP. So it really just depends on the type of request coming in. And also, like the REST interface for the metadata, I believe it's like if you're adding a piece of metadata, it's like a simple post to that path, to a data object or collection path. And that's basically passed directly from, the HTTP GET string into iRODS.
Excellent. All right. I will be definitely diving into that repo and putting something together.
Awesome. Good to hear.
Yes. Thank you, man.
You have concurrent gets in that example code too, right, John? There's Go routines doing essentially a multi-part HTTP for the gets, right? Or is that not in that one?
So the concurrency is handled using the HTTP range headers. So if you've got a client application such as like ARIA, and I think there's a few others, it'll actually first send out like an HTTP request asking for like the total size of the data object. And based on the number of threads you specify, it'll send multiple HTTP requests out concurrently. And through Golang, each of those requests is spun up in a separate Go routine, and each of those Go routines creates a connection to iRODS. So it's really a one-to-one mapping of those HTTP requests to the iRODS connections.
Yeah, that's all. So there's concurrency backing the ranged reads already. That's good. Okay.
Hey, John, I have another question. This is Cesar. You showed an upload option, right? Is it possible from your demo to actually do an upload of basically, let's say, a nested folder? And what happens with the structure, the hierarchical structure of that collection? If you decide to upload a folder that has subfolders inside, does that structure then gets recreated in iRODS?
Yeah, so that's actually a great idea that hasn't been implemented yet. Right now, you can only upload a single file, which I guess isn't super helpful for uploading large amounts of data. But eventually, I'd like to implement the JavaScript API where you can drag and drop a folder to somewhere in the UI, and from there, you could break out the hierarchy and then put those files into the applicable collection.
Gotcha.
So it's coming. But
right.
Yeah, that's a great idea.
All right. Yeah, it's a race. No, it's not. Collaboration. Yes. Awesome. Thank you.
Anybody else? Cesar was just trying to trick him into doing everything.
Yeah, I was in the background telling him, John, that's a value add. but we really, I mean, that's one thing we want to talk with the community about too is, where can BioTeam add value? We want to see this keep growing. That's why we see that, and I think I'm just taking as feedback that this was a mission accomplished, that by pushing the HTTP server kind of template in there to whet people's appetite, it kind of makes this binding real for folks immediately. So that's good.
Definitely.
Absolutely.
Yeah.
I think you're exactly right. Real is good.
Go right ahead.
What is next? We had talked about, so we've got here on the screen kind of a live version of what we demoed tentatively as a screenshot in June. We have now, so this is Terrell, and I'm talking a little bit for Justin, but he's going to come drive the computer here in a second. The idea is that iRODS with 4.2 now has a pluggable rule engine framework. And so one of the rule engine plugins that we have now written and have all but released, it's not in CI, so it hasn't been pushed as a published package yet, but it is open source and it's out there already. Allows for every operation inside the rule engine framework to emit an AMQP message. So we're calling this an audit plugin, and the idea is that every pre and every post PEP, as well as every static PEP, well, that's not true. It's just the pre and posts, are emitting an AMQP message with the full context of what's happening inside that operation.
That includes static PEPs.
It does include static PEPs. Okay. And so, as a standard, the AMQP messages now can be just pushed out onto the network. And the idea behind that is that now that we're not a special snowflake anymore, you can use industry standard tooling, probably some of which you may already have inside your infrastructure at the enterprise level, to do fancy things and ask it questions and make pretty graphs, write reports, and make sure everybody understands what's happening. So on screen here, we've got the iRODS audit plugin on the left, emitting AMQP 1.0, and it's been demoed both with, you know, a little smaller? Yeah. There you go. That's Ben Keller, everyone. So we've demoed it both with ActiveMQ as well as Apache's Apollo. They are equivalent from the perspective of the fact that they do a really good job of listening to AMQP messages coming across the network, and then they hold on to them. iRODS audit plugin can be configured to emit these messages either on topics or queues. So out of the box, it's a queue because we want people to not drop these if they didn't have all their stuff set up quite right. But you can just as easily configure them to be topics, which means that you can put them on multiple broadcast channels and have all of the enterprise machinery you want be listening to these things and pick up the messages. So for now, it's a queue out of the box. It goes to ActiveMQ, gets stuck there. And then the ELK stack, aka the Elastic stack, now of Logstash, Elasticsearch, and Kibana, over the Stomp protocol can pull those messages out of ActiveMQ, or in our case for this live demo, the Apollo server, and then parse them, put them into Elasticsearch, and then Kibana can be configured to pull those messages out of Elasticsearch based on queries. Those can be put together into graphs, and then those graphs can be put together into dashboards. And so after all of that, here's a post with so many words that says the same thing, probably completely unreadable over WebEx as I scroll. But the point is that in the end, you get to a graph, which out of the box is showing you a line graph with the number of connections per minute, number of unique users, and then we have some bar graphs for bytes read and written per minute per server, which is actually pretty interesting. So you have a lot of servers. You can now see which ones are doing the most work. And then the last two are designed to allow you to see for the first time, probably without looking at shadow of data, but the real data to see which users and which client IPs are actually doing the most work hitting your iRODS infrastructure, either just for monitoring or in case somebody's doing something bad, you can know that and turn them off. So in June, it was just a screenshot with some arm waving and bold promises made. And as of October, I guess, we got this live demo working. The only thing that is not downloaded from the internet somewhere else is the Audit plugin. Everything else is just a configuration exercise with other people's software. So this little script over here, Justin, do you want to talk about it, or me to kind of keep going? You can.
Yeah. So what I did is basically, because I wanted some interesting information on these graphs, I wrote a script that just has a little bit of randomization in it. It creates a random size file. It puts it into iRODS and gets it back from iRODS. That's why you see the bytes written and bytes read are pretty much mirror images of each other, because I'm writing the same file that I'm reading. So in a normal case, you wouldn't always read the file right after writing it. Anyway, so this has a little bit of randomization. It also the script also writes under two different users. I'm sorry, it writes to two different resource servers. So the first write, two different resources. So the first write would go to demo resource, I think, or resource 1, and the second one goes to the other resource. So I get two different resources being written to. Sorry, you're going to see the resources that are on the server itself. So I'm writing to the ICAT, direct a resource on the ICAT, and then I'm writing to a resource on resource 1. So basically the idea of the script was just, 1, to test it out, and 2, to kind of give you a nice, pretty picture of it running, while it's running.
Do you have credentials? Like, what's the login for? Is this a RODS situation? Somebody else hit it right now from a different machine and add to our graph?
They can hit it RODS, yeah.
What's the IP?
It is, sorry, let me go.
Is it the IP on the screen up there?
Yes.
Okay,
yeah,
so.
if anyone has a client, they can.
Yeah, if anybody has iRODS already running, you can put a file into, is it this IP up here?
Yep.
So 152.54.9.2.11, and it's, I guess it's temp zone 1247 RODS.
Yeah.
So if you do that and it works, we'll see another client IP down here in the bottom left-hand graph.
Yeah, and I had just done it while I was sitting there. That's why this is actually from my desktop in my office. And also, if you want to try different users, user 1 and user 2, passwords to user 1 and user 2.
If you want to track other statistics like changes to access controls, how hard would that be?
I suspect not that hard. I don't know all the dynamics. It would just mean that you'd have to find the dynamic path that kind of, whatever is the best candidate of telling you that something happened.
It's not at the API. It's not at the API call level. It's at the operation level. So you're looking at the shadow of an you see the result. But yeah, you could graph the number of times somebody has changed permissions.
Right, but I have policy control points.
That's right.
And so if they're sending out a message, then I can see whenever an access.
That's right. Now, it may not be interesting except for like account purpose to do it as a time series, but you could definitely see that type of activity.
Yes, it might help to actually go in and see what one of these is doing. So let me do the bytes written per minute. So we're looking for a rule that's named audit path resource write post. That's the path that I'm using to indicate that someone wrote some bytes. I'm doing a histogram with the x-axis, and I'm going to do an interval of every minute. I'm aggregating
By host name. Yeah.
the field, yeah.
Yes, that's splitting the input by the different hosts. And so he'll graph the top 10 at this point. The top 10 host names would appear on the right in the right column, but all those are configurable.
Oh, and the field that I'm graphing, sorry, I'm just a little confused looking at that, is int. It's not very, that field name doesn't actually tell you a whole lot, but you have to look into the PEPs and say, oh, well, the int is the number of bytes that were written in that segment that it correspond to that PEP. So I have to sum all of those up.
Can you show what one of these payloads looks like?
Yep. So what I'm going to show you now is the log stash. This is the output of the log stash. It's scrolling by pretty fast, but so what we're seeing here is, so at this point, the plugin has detected that a PEP fired. It's written a message to Apollo, and the message itself is JSON formatted. Logstash reads that, actually parses the JSON, does a little bit of manipulation of it, and writes it to the database. And this is the output of Logstash of the JSON for each PEP. I can control C it, so you can see it a little better. So like what I have up right now is a network read, and that's on the icat.example.org.
Yeah, so by default, this is out of the box. The regex is set to star, so it's going to produce this output for every PEP in the entire system. Obviously, you can dial that down to only do the things you care about. But that's a.
So how many messages per second?
We actually don't. That's an interesting one, Justin. Just total messages coming through the system. I don't know. We haven't.
What was that? I'm sorry.
Just total number of messages. How many messages are being emitted by iRODS per second?
I mean, you can certainly do it in Logstash if you wanted to. I don't know. I can tell.
I know that an ILS is approximately 1,200 PEP fires. So every one of these gets and puts is at least that, if not a little bit more, because it's doing more network activity and lookups than an ILS would.
Here, you can look at the number of messages.
Looks like it's 27 messages per second.
Yeah.
With whatever his script is doing. But that's going to be a function of activity at iRODS level.
I believe since I've been running this, it's been 590,000 messages.
Yeah.
Through. That was started probably an hour before this demo. So yeah, you can get some of that. You can get it if you wanted to. You could get it out of the database, or you could maybe do it in Kibana if you wanted to see the total number of messages, or you can look and get it from the message broker.
But if you're looking for load on your system, you can also look at connections and numbers that mean a little bit more than just an
Well, I was thinking of, for instance, Johnny's installation.
Sure.
Where he's got 100,000 connections a day.
Sure. So it looks like somebody else put a file in there because your graph is has an anomaly.
Oh yeah, big file. So let's go back to the dashboard.
So we have a new client IP.
I do have a new IP.
So who did that? Who's 271?
That's iRODS, but then it's covered in there.
Oh, Eric Scott wins.
In fact, I'm just putting the same file on there 10,000 times. So
nice.
I give it the same names. It's not like it's on the desk.
So if anyone's interested, so this I have the audit PEP resource right post, which is what I was using to identify the rights, and there should be an int. You see it? Okay. So for this particular one, this is the value, the number of bytes written.
But you can see, who the user is, you know where it's going, what zone it's in. full context of what's happening in that operation was shipped over the wire to, you know, whoever was listening for that.
Right. And the int, you just kind of have to figure out right now what that is. I mean, you know, I had to kind of search for what the right PEP was and what the right. So what we do is there's actually a lot of them that go to the rule engine that have int as it. And what I do in the rule engine plugin, the audit rule engine plugin, is I just increment. So if there's another int in this JSON, it would be int 2, int 3, and int 4. But they always are in the same sequence, so then you know, oh, I need int 2 for whatever I'm looking at, or whatever. And if you're interested in looking at the rule engine plugin, I can do that real fast. So here's the plugin code. It's not very big. This first part, this counter map, is just a map so I can, if I get any duplicate field names, I keep a counter of them so that in the JSON, they have unique names. I read the configuration. If you look at the blog post, there are some configuration settings that are used. As I find it, oh, right here. So this is how you would configure in the iRODS server config the plugin. So you would say you have a regag, so it would write this on each path and plugin would look for anything that starts with audit. This is a queue that you're writing to. This is the location of it. In my case, I'm just writing the message broker is on the same machine, so I'm writing to localhost. So anyway, the rule plugin, if I can find my cursor. All right, someone help me find my cursor. Oh, there it is. So the rule engine just reads that configuration that we just saw, and then it has a little bit of code to start on the start. When the server starts, the rule engine plugin will start, and it just does some message start to get a connection to the message broker. Then the rule exists. We just look to make sure that we have that audit underscore. If it is, then we know, oh, that's, yes, we have a rule for that. And then we execute the rule, and all it does is read the information from the rule and writes it to a JSON object. And then writes that JSON object to the message broker. It was defined in the configuration. One thing I did do is begin JSON and end JSON. Unfortunately, the message, when it's reading it from Logstash, it actually gets a lot of message broker headers or something. So the actual message that I want, I began with it, begin JSON and end JSON, so that I knew where the message started. I can show you the Logstash configuration just to give you an idea of what it does real fast.
You're checking for characters then that JSON doesn't like.
What's that?
You're checking for the characters JSON doesn't like. I get characters and path names that are invalid for JSON.
Yeah. So here's the log stash. It has 3 sections: input, filter, and output. The input just reads messages from the stop protocol from the audit message queue on the local host. Pretty simple, it doesn't do much. In the filter, it removes everything that's not between the begin JSON and end JSON. Then we need to parse the JSON message. I have to do a little bit of, I need to change my timestamp because Logstash will automatically append a timestamp to it, but the event itself already had a timestamp in it, so I overwrote the Logstash timestamp with the event timestamp. And then I convert some of the fields to integer. The database needs to know that it's an integer for all the reporting to work correctly. And then I just write everything to the database. And then Kibana will go and read the messages from the database. That's pretty much it. One more thing I did, if you're wondering why I use bar graphs here and regular graphs on the other ones, it's because Kibana does something weird when, if you have, say I'm breaking it down by minute and I have like 5 and then no entries for a few minutes and then 1, it'll draw a line between the 5 and the 1 rather than drawing the line down to 0. So for the bytes written, it makes a lot more sense to do, because the bar chart, as you can see right here, the bar chart lets you know that there was none there, instead of giving you some kind of weird graph that connects 2 points. So it just seemed to make more sense for that. But.
So the next challenge is looking for correlations between the measurements.
Yeah.
And the standard one are the correlations required for protected data. Logins that don't succeed, changes to access controls.
Yeah, we thought about looking at broken things, but that was until we had something that actually showed where things were working. Seemed premature.
Then you have a large number of people at UNC who need it.
Yes, because then it becomes an actual debugging tool.
BioTeam may have customers already. We are recommending iRODS combined with SDN for auditing protected data and dynamic network configuration and things like that. So this is really cool stuff.
Awesome. Well, it is almost 7. If there are any other questions, if not, we may cut this to an end here. Thank you so much for connecting. Jason had to go call Australia. It turns out it's tomorrow there already. We appreciate you calling. Thank you so much for doing the demo, Scott.
And I think he's talking about having the user group meeting once a quarter. We've talked about once a quarter. We've talked about
this meeting.
This meeting. We've talked about some other things, but it sounded like he was leaning toward once a quarter.
Yeah, I think that's probably about right. If you have strong opinions, otherwise, let us know.
Yes, please.
Thanks, Aaron. Good job.
Thank you, guys. This is always great to connect with the community. So
totally hire him. That sounds good.
Yeah.
Totally hire who?
John.
John.
Oh, we're way ahead of you there. Yeah.
I know.
That was an impressive demo.
Yeah, I mean that gives you a taste of that's our whole methodology, is to take Go and apply it to C and C++ system level architectures. We think it's the way of the future, and we think this helps maximize what iRODS can do for our customers as well. So yeah, thank you for having us.
Excellent, excellent.
Yeah, awesome, man.
Talk to you soon.